Dirty Scrap Podcast.
Thank you for making time for us, and I really appreciate it. And let me just say that for us, having you here in the Dirty Scrap podcast, a really, really good approach because we will talk about so many different things, and I am very excited about it. I just want to make like a quick introduction because I know for me, I was making my research about your background, and it's very interesting how you jump from let's say a financial point of view, and then you right now are into the sustainable and green trends. So I want to start this podcast, and just for the audience, I mean, this podcast is getting into more and more, let's say, different type of approaches, not just aluminum recycling, but we are getting more involved into the, let's say, sustainable point of view of the economy in general, right? So I know your bachelor is on commerce, but then I also know that you've been in several industries as CFO. How this journey brought you to, this path on circular economy, sustainability, mining, smelting. So tell me a little bit about you. And again, thank you for being here with us and making time. And let's dig in.
Sure. So yeah, I got my bachelor in commerce, and I focused in accounting in that baseline, and started working out of university for a coal mining, and worked my way through different pieces of that. And eventually, I was a controller at a on site at a mine site of a coal mine.
Okay.
And then got an opportunity to move over into a contract miner in the oil sands, and was the CFO there, and then moved into a more business operation role. And then after a while, looking for a different opportunity, started with Regenx. And when I first joined Regenx, it was your traditional junior exploration company. Found properties, dug holes, looked to try to increase the value of what the property was. And just before I started, they had sold one of the property. And when I came online, we started looking at what we actually did and what we should be doing. And the decision was that there wasn't great economics in just trying to find more properties, just trying to dig more holes. And so we looked at what else could we be doing.
Right.
And came across a technology that was a processing technology that was going to process old tailings of mines in areas where water was scarce, because it had a water recycling portion to it.
Okay.
And so we were starting down that path, and that morphed into being approached to see, could we modify our technology to work in e-waste? And then as we were in the e-waste, our current partner, Davis Recycling, approached us and said, I have an opportunity in catalytic converters. I need somebody who can process these types of catalytic converters. Does your process work for that? And that's how we ended up in that market. How I've ended up is I've always believed finance isn't its own silo. If you don't understand operations, you cannot understand finance, and both ways.
Agreed.
So I never believed that the job of the accountant as the CFO or any of those types of things was to sit in an office and look at spreadsheets, because you've got to understand your business to be able to do your job effectively. And so I've always had that operational bent. And then as the time's gone through, especially with Regenx, took more and more of a push towards the operational side. And so what I found is I have a great blend of economic background, but a great understanding of how a business works and should work, which allowed me to focus in on the operation.
Okay. Interesting, because before we jump into the technology and all the approaches and everything, I want to talk about some things that, because I don't know, Regenx is a company that started like in mining and everything, and I want to go in that direction a little bit, but talking about more general discussions about mining. But what you are just saying is a really nice approach, because every time that you are working with a CFO, they are just focusing, sometimes not all of them, but they are just focusing on accounting and numbers. Yeah, and this needs to make sense, and then you throw everything to the operational guys. But your approach is a little bit different and allow me to go in the direction of the circular economy, because at the end you need to understand the whole, right?
Yeah.
Talking about circular economy, and I can see, I don't need to ask you, why you are like circular economy, because I just heard you what you're saying, but what do you think about the circular economy and why the circular economy is getting more and more important? Because for me, circular economy was something that was out there and was on the large scale, but you can also implement circular economy inside your company and your processes. What is the approach that you are having for the circular economy?
Well, we see in our specific is there is not going to be enough economic platinum, palladium in the ground for the
Right.
future. And
Definitely.
those are critical minerals, metals for the future of transportation, of electronics, of, fuel cells, all those pieces. Those are critical metals in that space. So you're not going to be able to continue to count on digging holes in the ground. Like I said, you can't count on that to be able
Right.
to supply the future. So we have to look to be doing better with what we've got already out of the ground. And we've got to find ways to maximize the usage, which means using it multiple times. And the circular economy solely is about how do we find ways to use the same materials multiple times to avoid having to find new sources. And that, even in your company, even on smaller scale stuff, that's what we're all looking for in efficiencies. Is how do we find ways to do things multiple times with less resources? And that's a fundamental key of how we grow any business. And so what we've got is just layered in as our product is part of that, but our process is part of that.
Right. Right. And let's talk about mine. As you just said, there's digging holes all around the United States. I understand what you're saying, and I'm totally agree that all the resources are not, I mean, they are limited, of course. So we need to understand a better way to reuse as much as we can whatever resource or what we want to, reuse. Like in my case, it's more aluminum or copper, brass, and how we can approach with different technologies to make it more efficient, but also to make it more profitable and to have better energy efficiency, low CO2 emissions ever. Now, saying that, I understand that mining in the United States is dropping down. We have some U.S. Let's say decisions from the government that is pushing us to close some mining here. How do you afford that you will need to close the mining when you have a product or a process that depends on what we are taking out from the soil to reuse it as much as we can? Because at the end, yes, we can reuse, but everything has a limit. Well, aluminum, you can do it whatever, as much as you want. Plastic is different, but in your case, what is your approach?
Our approach is that there is a bigger underused source. Right now, what we have is that there is a big chunk of what we have that's going back into the ground through landfills, through unused, through that. So only 35% of the total demand was covered by recycled materials in 2023.
Only 35%? Oh, wow.
Yeah,
That's low.
that's low. So there is what we have right now is that you're taking it from the ground and then we're putting it back in the ground after one use, but you're putting it in areas where you can't get it. So we have to get places where we can cut that so that you've got multiple times before it hits the ground.
How?
So what we have is, we're kind of lucky in what we're doing, is that there's really a already pure existing sort of supply chain for what we're doing. And automobile scrap is a mature industry. It's one of the most mature recycling around.
Yeah.
But the reason that a lot of our product isn't making it through that is that the dominant recycling method for catalytic converters right now is smelting. It's big smelters. So really you're just putting it into a big furnace and melting it back down to its composite. We're focused in on what's called silicon carbide diesel catalytic converter. And that means that the regular gasolines are mainly based off of a ceramic type honeycomb where the precious metal is coated on it.
Okay.
The silicon carbide is the honeycomb is made of a silicon carbide, and they have to be, for diesel engines run hotter than a gasoline, and so they have to be a much more robust substrate. Being a more robust substrate, that means that if you try to throw it into the furnace with gasoline, you get inefficient because it doesn't melt as well. So it causes issues in the smelting. So traditionally smelters have said, we don't want this product. Right. And so down the supply chain, they said, well, it's not worth us to try to recover it. So there hasn't been an opportunity for this to be used. What we're now doing and through our supplying is pushing down the word to the smaller guys down the chain that, hey, there's a home for these. Start taking them off the vehicle. Don't just crush it with the rest of the vehicle.
Right.
Pull this off, and there's going to be a home for it. And so that's how we're pushing to get a bigger piece of the pie, is pushing down the message that there's value here. Where there once wasn't value, there is now. And there's value for you to do the work, to take it to be able to process it for us.
Is the volume of this material big enough to get into new processes and making like maybe more industries have more interest about how to reprocess this material, or is just good enough for a few companies?
I don't think there's material that's huge amount,
Right.
but there is a substantial amount of material available. And it's a market that part of the reason it's been a niche and hasn't been is that historically the diesels were not required to have the catalytic converter. And so they were the last group that had emissions requirements on them. And it's become a greater piece of requirements for emission control. And it's been added to more things than not just the vehicles on the highway, but into the mining yellow iron, into diesel generators, into marine. All those ones, the regulations have become more and more strict.
Right.
So there has been a increasing amount of product that has had this requirement. And now that's starting to come into the supply chain. And that's going to continue. Because you're 10 to 15 years away from a regulation to the scrap side because you have the life of use into that piece. So
yeah, what are the applications for these type of materials right now?
Right now, the majority of those go back into new catalytic converters.
Okay.
Like for palladium, 80% of palladium is used in catalytic converters. Platinum is a lot more diverse. Industrial, investment, jewelry, those types of things. But the majority of what we use is truly circular. It's going right back to the same product that it came from.
And you are just saying that just 35% of this approach are coming from recycling.
Yes.
And the rest are coming from mining, or like
from mining, from traditional in the ground source.
And do you think that this 35% that is coming from scrap or recycling is the 100% of the waste, let's say, material we have out there? Or
no.
Okay, how percentage this represent for you to have an example?
It's not, that data is less clear, but it would probably be around the same 35%.
Definitely.
Because when you look at what the historical trends of how much is used versus the recycled, well, the usage has stayed fairly static. So you know that there is that amount of recycled happening because all the ins and outs are sort of in balance.
Right. And because this is very interesting to me, because I am seeing here a trend. I mean, if you go to check the aluminum recycling rates in the United States, let's talk about UBC, used beverage can, the cans that you are using for drink, whatever liquid or you want to drink, right? It's 40%. Here in the United States, the recycling rate is 40%. So 60% are going to landfills. And I don't know if you are aware of this, but we have 90 million tons of aluminum in the landfills in the US that we can dig up to reuse it. So I can imagine that these type of material that are more expensive and way more complicated to work with are going to landfills. How is the treatment when we send this material to a landfill? Because it's not a simple material, it's almost on the nuclear type, right?
No, it's fairly benign.
Okay.
Like the catalytic converter is a fairly benign. Your silicon carbide is a benign thing.
Yes, I use silicon carbide in some applications.
Yeah. So that sort of thing isn't, but anytime you've got any metals in landfill, I mean, rainwater stuff, all those oxidizing, all those types of things, they can cause issues there.
Right.
But I wouldn't classify it up on the high toxic. And it's like anything, anything that we've processed as a mankind, when we put it in the ground, we cause issues with groundwater, just because it's not supposed to run through that stuff.
Right. So your company saw an opportunity and you are walking in that direction. How the process works?
So it's It's a simple but complex.
Okay.
It's from the 10,000 foot view, it's a very simple process. Getting it to work efficiently is the complexity of what we do. So what we do is proprietary. So I'm going to be a little bit vague, but give you the highlights of it. Fundamentally, we take the material, our partner grounds it into a fine powder that has the precious metals in it. We then put that into a chemical leach to separate out the precious metals from the substrate.
Right.
We separate those solids and liquids. The liquid now is a precious metal bearing liquid, which we call a PLS, a pregnant leach solution. So we then take that pregnant leach solution and we run it through what is effectively commonly called Merrill-Crowe precipitation, which allows us to drop the precious metals out of solution into what is we call a black powder. So it's a dirty concentrate. That dirty concentrate is a high percentage precious metal material that we ship to a refinery who then processes it, upgrades it to 99% pure metal, which is available to sell into the commodities market.
Right. Is the refining process chemical process or is a melting process or?
They use a little bit of both. I think, so it depends on which metal they're going after, I think, but yeah, that's their third party piece there.
Right. So your process comparing to, let's say, the smelting process, I can imagine that the smelting process is very high energy than the process that. So also we can say that this is an eco-friendly process, right? Do you have any idea about what difference you have between, let's say, CO2 emissions or energy approaches against the, let's say, primary one?
So we use 95% less energy, 99% less water than mining, and a smelter for a ton of processing emits 1,500 kilograms of CO2. And so we're next to nothing on what we do on CO2 emissions.
And do you have an idea about what is the percentage of recoveries are you having on this process? Because for give you an idea, if you go for an aluminum, let's say, perspective, obviously it will depend on the technology and the type of material you are processing, but you can be between the low 90s up to 98 melting efficiency. That is really, really good, but you need, as you just said, like sorting processes, very clean and good approach of sorting and segregation. And I can see here is pretty much the same, right? So do you have an idea about the recovery that you are having on this material? Because this material looks like our expensive material.
Yeah, we get over 95% consistently.
Oh, it's pretty good.
Into the 98.
What makes the difference between the 95 and the 98?
Some of it is a little bit on whether or not there's impurities in the piece. Those are the major part, is that if you've got some of the more impurities in the raw feedstock, it will create you don't get as efficient leach.
And talking about, let's say, from the point of view of the scrap metal economy, what is the approach that you're having? Because I know that you're having a different approaches, right? Sustainability, eco-friendly technology, and recycling. Is mining still something that you guys are doing right now, or is completely out of the loop?
Completely out of the loop. We still have some legacy projects that we are divesting ourselves of, but our whole entire focus is on this sustainable green technology baseline, and has been for a bunch of years here.
Let's talk about the size of this technology, because I've been talking with a lot of people that is going in this direction in different industries. And it's amazing how all the different industries at the end merge together in just pretty much the same point, that you can apply these different approaches to different industries as well. In this moment, what is the level or the scale that you have developed your technology so far? So
what we've built right now is what we call Module 1. It's the first line in our plant, and it's rated to run at 5,000 pounds a day. So that's where we're stepping up to, is to run at 5,000 pounds. Our plan is to add 4 more modules in our current location to be doing 10 tons a day of feedstock.
Got it. Who is your source of this type of material?
So we have a partnership with a large recycler, Davis Recycling, who has a reach of 13 states in the eastern seaboard of the U.S. So he's our primary source. Other sources we're developing is to work with OEMs, to directly work with the large engine manufacturers to become a circular option for them.
Right. Is this material also globally being treated in the same approach? Or, I mean, because for sure, mining this material in, for example, China or Russia, or should be something big, I think.
So the major mining places for this material are Russia and South Africa. South Africa is your
Right.
major. So there is geopolitical issues with the current mining area.
Okay.
Russia is Russia, and South Africa has infrastructure issues, power grid, all those types of things, which makes the ability for them to be a consistent supplier is somewhat in doubt.
And as a CEO of a company like Regenx, what do you think about what is happening from the point of view of closing mining here in the US when we want to grow some industries like the EVs, right? That we need a lot of, say, I will not say mining, but we need cobalt, for example, for the anodes. And we have 77% of China, leading the market in this direction. So it looks to me that is we are pushing to an industry that is depending on third parties that we don't have a really good relationship at all for saying something. So as a CEO of a company that's been in the mining industry and is working on the recycling side to, make products more reliable and lower down the CO2 emissions and go with all these trends, what do you think about it? Because at the end, looks to me that we are pushing very hard to get in one direction, but at the same time, we are, let's say, giving up on some sources here in the US. So we are creating codependency on third parties that maybe can affect the best way to move in this direction.
So I think that the US government is starting to realize that issue. And one of the ways I see that is that the work they've done on critical minerals, identification, supply, all those things. So they've now done the work of understanding what they need to be focusing on and why they need to be focusing on these pieces and what are supply chain deficiencies.
Mm-hmm.
And so with understanding what the problem is, then it starts to move into how can it be remedied?
Right.
On the other side of that box, some of the current issues around bipartisanship and sort of those types of things make counting on the government to enact things very problematic. And so it looks like the departments of the government are doing their job. Now it's up to understanding, is our legislators going to start doing their job instead of just playing politics?
Right.
And until legislators decide that doing their job is more important, then the US is going to be at risk.
Right. Definitely. I am agree. And from the point of view of price, because South Africa, I think the price should be very low compared to the US price. It is competitive for us to keep working with this market, or what do you think? From the CFO perspective, right?
Yeah. That's a hard question to answer because each mine is different.
Right.
It's about understanding the economics of a mine site. How deep is the resource? How all those types of things is more important than where it's located some of the time, because fundamentally, with the way mining's gone on, with size of equipment, with efficiency of equipment, labor is such a much smaller portion of those pieces. And so when you compare to something like Russia or South Africa, I don't think they're getting a large benefit in labor towards the bottom line, even though it's cheaper than you are comparing to the US. But it is on geology more so than labor is where I see the issue.
Right. So where I understand it, you're saying, so they will have maybe larger resources than us.
Yeah, closer to the surface, that you have to move less dirt to get to, those types of, all those geology issues of, if I dig 100,000 tons of dirt, I'm going to get 10,000 tons of product. Or if I dig 100,000 tons of dirt and I get 5,000 tons of product.
Yeah, that makes it way different. Yeah.
Way different. Labor has no bearing really on that economic.
When you approach to a mine, how do you calculate the profits, or how do you say, okay, this is a good mining spot that we can, have good profits out of it, and we don't need to have too much labor, because at the end, mining is expensive and it's complicated, right? So how do you define a good place to work?
Well, It's about understanding, it's all on your mind model, is that how efficiently can I get to that resource?
Right.
How much dirt do I need to move to make that resource available to be pulled out of the ground?
Right. Right.
And so you're really looking at your mining modeling type thing to determine what your economics are. The other side of that is understanding, like, really, when you make an addition to mine, it's sort of a 10-year out before you're actually digging dirt.
Oh, really? That much?
By the time you do all the permitting, exploration, planning,
10
feasibility
years.
study, you're 10 years at least before saying, here's a piece of ground, I want to be mining it. And 10 years is a fast process. And
Fast?
so, yeah, that's a fast process from looking at a piece of ground and saying, okay, we think there's something here, to being ready to put shovels in the ground is a minimum 10 years.
Oh, wow. And that is a fast process. I mean, for me, it's like a crazy, too much time process, but definitely, yes, we are talking about mining, right? It's colossal.
And so, speaking on that, the economic side isn't just, okay, how much is it going to cost me? Is what's the value projected to be of that metal 10, 15, 20 years out? That you're not, is that if a price is high today, doesn't mean that you're necessarily you're going to do that, because it's at a high point, but I'm looking at economics out 10 years, we expect it's going to be dropping. So it doesn't make sense to start doing that.
Right. Do you have any idea about how the financial guys approach to this long period of time? Because at the end is market, right? So you cannot control the market. Obviously, you have an idea, and you have, let's say, the information of the new economies that are, moving forward and can use these type of materials in the future. But at the end, how do you make a calculation to say, okay, I will spend this type of time and amount of money, and this will give me like 100x or whatever it is to make sense?
So a lot of that's done through sensitivity analysis. So saying, okay, if the price is X, this is our return. If the price in the future drops 20%, 30%, or whatever, because you can look at how prices have been, how much volatility there in the price.
Oh, yeah, definitely.
Historical. And so you can lay that sort of volatility onto future looking pieces and say, okay, if I take current price and I say that there's a volatility of 30% one way or the other, I can then say, here's my range. And then if at the bottom end of it, it still makes sense, well, then you've got your risk side of saying, okay, here's my variables, and I've run all these sensitivities of here's my best case scenario, here's my worst case scenario. If I believe, and how much do I believe the probability of each of these cases is, which then you can lay into a model and say, okay, based on all these probability analysis, here's where we project what the piece would look like.
It's a beautiful job. I mean, very, very risky.
Yeah.
So you work in a range. So if we are here, we are super good. If we are here, okay, makes sense, but it's very sensible.
Yeah.
From the point of view, for example, of the aluminum goals we have by, I will say 2050 is to have at least 90, let's say 87, 90% of the aluminum that we will use is going to be recyclable aluminum, right? So 90% of the aluminum will be recyclable aluminum in 2050. Now, saying that, to go in that direction and to reach those goals, to get into those numbers, we will need at least 19 million tons out of the mining of the primary aluminum industry in order to get into those numbers. Do you think it's going to be pretty much the same in order for you to keep moving into the recycling, let's say, trend in your industry? You will need to keep the minings open for a while to have enough material to in some point say, hey, yes, we're good, we can work with what we are recycling.
Yeah, we believe that the mining's not going to stop in these pieces, partly because all these markets for catalytic converters for these precious metals are growing. I mean, there's more cars on the ground, in the world. There's more of these. So we keep growing the requirement, which means you can't say recycling is going to cover 100% because you don't have as many original ones as you currently do.
Definitely.
So grow, if you're in an industry that's growing, you always need primary supply because there's not enough, even if you recycle 100%, you can't cover what the growth profile.
Yeah, 100%. And I think the first approach is not going in the direction, we can close the mining, is more on the, okay, let's make that 35%, 50%, and then 70%, right? How?
So what you're looking at is where I look at it is increasing in recycling is how you're going to cover growth.
Right.
That you need to increase recycling to cover growth because we can't count on more production from mine. There's just not that many mines ready to come online to cover growth. So if you're going to grow some market, it's got to come from existing sources, which is the recycling side.
Definitely, completely agree. And what is, and please sorry for my pronunciation, but these catalytic converters, or how do you pronounce that? For me, is not easy.
Catalytic converters.
Right. What is the use in the industry right now? What are they used for?
So
I can imagine that several industries, right?
Yeah. So catalytic converters are mainly on combustion engine, and what they were built for is to take toxins out of the atmosphere. And so what they create is the I won't have the technical term, but the NOx and SOx and carbon monoxide. So they were there to stop those harmful pieces. They do not help with CO2. They actually create the CO2. But
so it's like a filter.
Yeah. So it converts these toxic gases that used to go into the atmosphere into, at that time, was stuff that's currently into nitrogen and CO2.
Right.
And so it was taking out harmful ones from the atmosphere. So that's the rationale for what they do.
Right. Now, saying that, what is the future that we can expect from Regenx, but also what is the future that you are planning in terms of recycling and circular economy and sustainability? What we expect, and how long will take this future to be on the field that we can really feel what is coming from your future?
So we've got an operational plan, and we're scaling it up. And right away here, we're going to be at 5,000 pounds. So that's our initial piece, and that sort of pushes us to be a profitable company. Then after that, we have growth plan, and we're going to continue to grow. And so then we'll be a piece of the market that's going to be helping with the growth and adding more of these precious metals into the supply chain. So what we see is we have a critical role to be able to take a part that's not currently being funneled through the supply chain and add that to the piece, which then will allow us to be able to work with OEMs to allow programs like their core programs, where they can just completely have a new product right from the piece that we give them back.
Right. How long you think will take this approach for you guys to,
We're looking to be at 5,000 pounds this fourth quarter here. So, and then growth will depend on ensuring we have the right supply. But it's not a long term, not a far into the future from when we're going to be a fully operational.
So it's more in the medium term, something like that. Is this model something that you can put in different locations, or is something that you just have in your facility and you need to collect everything?
We built our first one to be close to our supplier. So he's in Tennessee, and that's why we built there. But we'd anticipate building a second operations out on the West Coast and based on geography there. And it's a module system that we would be able to put up wherever in the world makes sense.
And because this is modular, it is possible to grow the system depending on the requirement.
Yeah. So we plan to do 4, but there's not reason that four is a limit. It's really what we supply sort of dictate what the optimal size of an operation is.
Right.
The reason we're doing modular is to make it more efficient in operation. If you do one thing that's just big tank, if one thing happens on a maintenance baseline, well, then the whole plant's done. But if you got modular, you've got multiple streams that you can keep running while you're doing maintenance on other pieces. And so your operational efficiency becomes much better.
Yeah, that makes sense, and it's very clever. And talking about byproducts, are you having any byproducts out of this process, or it's completely clean?
So once we have everything out, it's all benign and nothing there. There is a tailings, but that's really the silicon carbide substrate. And so our partner's looking at some industrial application for that, which he's hopeful that we'd be able to just completely use the tailings for.
Right, but well, actually, silicon carbide is something we use in the melting industry as graphite or different type of refractory materials. And are you using this material? Are you approaching to this industry to see if they can qualify your silicon carbide for like something that they can use in the process?
Not yet, but it's there's a bunch of pieces that we're trying to see what works the best. Right. And so all those options are on the table.
Okay, yeah, that makes sense. And to wrap up the episode, Don, I really appreciate it. I think it was very interesting talking about the mining and everything we are seeing around the globe and how Regenx is approaching to these issues. And it's very, very, let's say, interesting, and I am very happy to know that people is not approaching just on the recycling side from the point of view of aluminum on the regular metals we have in our daily basis, but also all these metals, precious ones that we have no clue that they are out there, helping a lot of different industries. And just to wrap up, as I said, what is going to be the next short-term step on Regenx?
Our next short-term step is operating at 5,000 pounds a day and being fully operational of module 1. And I'd just like to say that, if people want to know more about us or want to invest in us, we're a public company. We're listed in Canada as RGX. In the US, we're listed as RGXTF, and they can go to our website, www.regenx.tech.
There you go. Yeah, that's supposed to be my final question. Where the people can look at you and find you guys? But yeah, I'm happy you brought it ahead. So, Dom, thank you so much for your time. Really appreciate it. It was an amazing episode, and I think the audience will they will understand better about all these different movements about sustainability, eco-friendly approaches, circular economy, that is not just related to a certain industry that is aluminum recycling, but is all around the globe. And people like you is putting a lot of effort to make this happen. So really appreciate it. Thank you so much. And hopefully, once you start your 500,000 pounds a day, we can have another episode.
5,000.
5,000. Yeah, I went too much. But 5,000 pounds a day. Definitely, we can have another episode to see, how this thing is working right now, because then you will see how easy it's going to be to scale this in the future.
Sounds great.
Dirty Scrap Podcast.